respect to ROC, specifically region of convergence. So different properties with respect to different properties of ROC, we had solved the problems. And in the last class we had done them, uh, we have done some derivations. So different properties of Z transform, like shifting, convolution, frequency differentiation, etc. So in this class, what we will do is we will make use of the properties and we will solve the problems. Okay. So yesterday was like, derivations. So today is the application of derivations. So without wasting much time, so let me start today's class. So what's the question here? Find the Z transform using properties. So whenever they give using properties, you have to solve using properties only. Okay. Make sure you solve that. So what's the question here? X of n is equal to n a power of n into u of n. So our question is x of n is equal to n a power of n into u of n. So using properties, we have to solve this one. So if you sorry for the call. Okay. So if you observe this problem properly, okay, so this is in the form of, n into x of n. So in yesterday's class, we have done some derivation with respect to properties. So what's the derivation we have done yesterday? So this one is particularly frequency differentiation. So yesterday I have done this frequency differentiation. So according to the frequency differentiation property, what is the Z transform of n into x of n Z transform? So Z transform of n into x of n is nothing but minus z d by dz of x of z. Okay. So this is the frequency differentiation property. So first what you have to do is you have to observe the problem. So x of n is equal to n a power of n u of n. So in your mind it should run, it is in the form of n into x of n. So this is n. So this is your x of n. So we can use this property of frequency differentiation, which says that z transform of n into x of n is nothing but minus z d by dz of x of z. So using this property, we will solve. So left side what we have got, z transform of n x of n, a power of n into u of n. So this is your left side. Right side, what is the problem answer here? Minus z d by dz of x of z. X of z is nothing but your z transform of x of n. So here if you observe, this is n, this is x of n. So what is your z transform of x of n? A power of n into u of n. So in the last, last two modules, so last two class, so I have derived this one. Okay. Z transform of a power of n u of n is nothing but z by z minus a, provided mod z is greater than a. So now we know this z transform of a power of n u of a power of n and u of n. So let us substitute here and we will get our answer. So minus z d by dz of z by z minus a. So how can we differentiate numerator by denominator? So minus z, denominator the whole square, denominator into differentiation of numerator minus numerator into differentiation of the denominator. So you further, simplify this. So you should arrive it as az divided by z minus a the whole square. So that is for you to simplify, to bring this in this form. So those things you have to do. Okay. So provided mod z is greater than a. So that is from this condition out. So let us see once again. So how did we arrive at, the z transform of n a power of n u of n? So by seeing this one, what we can say, it is in the form of n x of n. So using frequency differentiation property, z transform of n into x of n is nothing but minus z d by dz of x of z. So minus z d by z dz of z transform of x of n. So x of n is a power of n u of n. So we know previously we have solved z transform of a power of n u of n is nothing but z by z minus a, provided mod z is greater than a. So substitute that one, differentiate, you will get the answer. So it is simple. Okay, just you have to remember the properties in mind and you have to apply here. Okay, so we'll go to second problem here. So what we have got, x of n is equal to n square a power of n into u of n. So if you observe the problem in your eyes, what can you observe? So we know that z transform of a power of n u of n is z by z minus a. Now n square a power of n u of n is there. So first we will express in the form of n a power of n a power of n into u of n. So we have got that from the previous problem, z transform of n a power of n u of n is a into z by z minus a the whole square. Now if we can express in terms of n into x of n and we can use frequency differentiation property, we can get our answer easily. Okay, so don't worry, we will go slowly and we will solve step by step. Okay, so what can I can write this one as, so z transform of n square a power of n u of n is there. Okay, so this is your question. So what I will do is z transform of n into n a power of n u of n. So why did I write it like this? So that I can use the property z transform of n into x of n. So we can use the frequency differentiation property. What does frequency differentiation property says that? So you have to write in the exam which property you use. Okay, z transform of n x of n is nothing but minus z d by dz of x of z. So now your n x of n we will substitute like previously and we will solve. Z transform of n into x of n is nothing but n a power of n u of n. So you can express this one as minus z d by dz of x of z is nothing but z transform of x of n a power of n u of n. So now from the previous problem we know z transform of n a power of n u of n. So we'll go to the previous problem. So what's the question here? X of n is equal to n a power of n u of n. So what's the answer we have got? 1 minute. ಹಲೋ ಮ್ಯಾಮ್, ಕ್ಲಾಸ್ ಆಗ್ತೈತೆ ಹಾಗೆ ನಾನು ತಗೊಳ್ತಾ ಇರಲಿಲ್ಲ, ಮತ್ತೆ ಮಾಡ್ತೀನಿ. ಓಕೆ. Okay, sorry. It was an urgent call I had to receive. Okay. So if you see the previous problem, okay. So now what is this z transform of x of n? So z transform of n a power of n u of n is nothing but a into z divided by z minus a the whole square. So this you have to remember. Okay, this previous problem. So we can use that directly here. So now what we have got? Z transform of n a power of n u of n. So what's the answer? Minus z d by dz of a into z divided by z minus a the whole square. So now it's easy. Just we want to differentiate numerator and denominator and get our answer. So that you have to do. Okay, so finally you have to arrive, so simplify that one. So this differentiation and all you have to do, you can do it easily. So finally you can arrive, you should arrive in the answer as a into z divided by a plus z divided by z minus a the whole cube. So this is for you to simplify. Again, differentiation of numerator by denominator and multiply by minus z. So these things you should do. You have learned in PUC. Okay, so let us see once again what's the logic we have used, because that's important. So given the question x of n is equal to n square a power of n u of n, I have expressed in the form of n x of n, because we can use the frequency differentiation property and we can get our answer. So what is the frequency differentiation property? Z transform of n into x of n is nothing but minus z d by dz of x of z. So n is this one, x of n is this one. So from the first problem which we have solved, and you have to keep this in mind, always z transform of n a power of n u of n is nothing but a into z by z minus a the whole square. Then d by dz is there. Substitute and simplify this one. Okay. And then you should get this answer. Okay. Okay. So let me go to next problem. Okay. So the question here is x of n is equal to n minus 1 the whole square 2 to the power of n minus 1 into u of n minus 1. So by the look of the problem only, you have to get which property you have to use. So this, it looks like time shifting, right? So you observe here n minus 1. So n minus 1 is there, n minus 1 is there. So directly you can use this time shifting property. So what is your time shifting property says? So let me write, first time shifting property, what it is. And based on that, we can solve the problem. So z transform of x of n minus n naught is nothing but z to the power of minus n naught into z transform of x of n. Okay, so this is your time shifting property. So why did I use this time shifting property? You observe the problem here, because n minus 1, n minus 1, n minus is there. Obviously, we have to use this one. Okay, so now z transform of n minus 1 the whole square 2 to the power of n minus 1 into u of n minus 1. So what's the answer here? Z to the power of minus n naught. So z to the power of n naught is 1. So z to the power of minus 1 into z transform of x of n. So what's your x of n here? Here x of n is n square 2 to the power of n into u of n. Do not confuse. Okay. So previous problem and this problem, there is a difference. See the property here. It is x of n minus n naught. Here it is x of n. So this is x of n minus n naught and this is x of n. Okay. So make sure you do not confuse. Okay. So we'll solve this further. Z to the power of minus 1. So z transform of, how can I solve this? N square 2 to the power of n u of n. Again we can use frequency differentiation property. So I will express this as n into n 2 to the power of n into u of n. So why did I express like this? So that we can use our frequency differentiation property and get our answer easily. Otherwise, if you remember z transform of n square 2 to the power of n u of n. So in the previous problem I had done x of n is equal to n square a power of n u of n. Using that one, you can substitute. If you remember the formula, you can write. Otherwise, we can solve like this. Okay. So how can we solve this further? Z transform of, so z transform of n x of n is nothing but, I'll write it directly, minus z d by dz of z transform of x of n, which is n 2 to the power of n u of n. So now further, how can we simplify this one? Z to the power of minus 1 into z to the power of plus 1, it is 1. So minus it is as it is, I'll write d by dz of, so z transform of n a power of n u of n. So first problem, so z transform of n a power of n u of n. What is the formula? A into z divided by z minus a the whole square. So that one I will apply for this one. So n a power of n u of n is nothing but a into z divided by z minus a the whole square. So now it is your your thing to differentiate this numerator by denominator. So those things I will not do. Simplify this one. So this you have learnt in your PUC, numerator by denominator, and I have also done for first problem. So you should arrive at answer as 2 into z plus 2 divided by z minus 2 the whole cube. So this you try. Simplify this one to get this answer. So let us, concentrate on the logic here. So given the problem, x of n is equal to n minus 1 the whole square, 2 to the power of n minus 1, u of n minus 1. So this looks in the form of x of n minus n naught because it is n minus 1, n minus 1, n minus 1. So we can use this time shifting property here, and we'll write that one first. So then you express in terms of that, and then you can simplify this one as frequency differentiation property. So this is n, so this is x of n. So z to the power of minus 1 minus z d by dz of x, z transform of x of n. So simplify this one, this part, you have to arrive at this answer. Okay. So this is easy. If you remember the properties, understand the properties, it's easy. Okay. So now we will go to another problem here. So again, if you observe this problem, x of n is equal to n minus 2 the whole square, half of n minus 2, u of n minus 2. Same logic as previous. So this looks like time shifting property. So then after that, what we have to do? After that, we have to express in the form of n into x of n and get our answer. Okay. So let us go step by step. So what property I can use? Time shifting. Z transform of x of n minus n naught. So write it here, time shifting. So those things are very important. Okay. So z transform of x of n minus n naught is nothing but z to the power of minus n naught into z transform of x of n. So now what is your question here? Z transform of n minus 2 the whole square, half of n minus 2 into u of n minus 2. So this is your question. So z to the power of minus n naught is 2, and z transform of x of n. So what's your x of n? N square half power n u of n, because this is x of n minus n naught. So this is x of n. So understand the property, and based on that we have written. So further, how can we simplify this one? Again, like previously, so n square half power of n u of n, you can express as n into x of n. So let us do that. Z to the power of minus 2, z transform of n into n half power of n u of n, because I can use frequency differentiation property just like the previous one. So this is n, so this is x of n. So what's the frequency differentiation property tells us? Z to the power of minus 2 into z transform of n x of n is nothing but minus z d by dz of z transform of x of n half power of n u of n. So again, like previously, what is the formula? Z transform of n a power of n u of n is nothing but a into z divided by z minus a them whole square. So using that, we can get the z transform. Again, we have to substitute and we have to get the answer. So how can we go about this one? Z to the power of minus 2 into minus z, I can write it as z to the power of minus 1. So minus outside, d by dz of, so observe here, so a into z, so your a is half into z divided by z minus half the whole square. Okay. So then you can take this 2 outside. So you can write it as z to the power of minus 1 minus divided by 2 d by dz of z by z minus 1 the half the whole square. So this you have to simplify. Again, it will take 2-3 steps. You have done many differentiation property in your PUC of fractions. So do that. So you should arrive at an answer as 1 by 2z into z plus half divided by z minus 1 by z the whole cube. So this one you have to simplify to this thing. So this is your answer. Okay, so that is for you to do. So let us see what's the logic behind this one. So given x of n, so first you have to use this time shifting property. Then to use frequency differentiation property, then simplify this one and get the answer. So it's just like the previous problem. So I have not changed any much here. Okay. Okay, we'll go to next problem. Okay, based on the same technique, I have given one homework problem for you. So here x of n is equal to n minus 3 the whole square, 3 to the power of n minus 3, u of n minus 3. Just like the previous one, time shifting property, you have to solve this one and you have to arrive at this. Use time shifting and frequency differentiation property, just like the previous one. How did I solve? Okay, so I think it will be easy for you. Okay, so let's go to another problem here. So x of n is equal to n plus 1 the whole square into u of n. So how can I simplify this one? So this is in the form of a plus b the whole square. So let me write it down. A squared plus b squared plus 2ab into u of n. So now we want to get them z transform of individual term. So z transform of x of n is equal to z transform of n square u of n plus z transform of u of n plus z transform of 2 into n into u of n. So this is your first term, so this is your second term, and this is your third term. So we have to solve each and everything individually. Okay, and then add up together according to linearity property. Okay, so this I have done according to linearity property. So let us take this first term. Okay, so first term, what we have to find out? Z transform of n square u of n. So this I can write it as z transform of n square 1 to the power of n u of n, so that it is in the form of n square a power of n u of n. So that will be easy for us to solve. So how can we simplify this one? So you can simplify this one as, so z transform of n into n u of n. So forget this one. Okay, so we have z transform of n square u of n. So I'll write in the form of n into n u of n. So you know that z transform of n into x of n, according to frequency differentiation property, z transform of n x of n is nothing but minus z d by dz of x of z. So minus z d by dz of z transform of n u of n. So now in order to get z transform of n u of n, what can we, so from the previous, so from the first problem, so z transform of n a power of n u of n, you have got as a into z divided by z minus a the whole square. So today's first problem I have solved. So z transform of n a power of n u of n. So you observe this one. So what we have, z transform of n, so a here is 1 and u of n. Okay, so a into z divided by z minus a the whole square. So a is 1 into z divided by z minus 1 the whole square. So this is your z transform. So minus z d by dz of z by z minus 1 the whole square. So again you have to simplify, that is your work to do. So I'll write it here, simplify, because differentiation and all you can do it easily because you have learned in your PUC. So you should arrive answer as z by z plus 1 divided by z minus 1 the whole cube. So this is the so still your problem is not over. So this is the z transform of first term. Still we have to get the z transform of second term, z transform of third term, and then we have to add together. Okay, so this is the z transform of first term. So we will do step by step. Second term we will do, then we will go to third term, and then we will add up. So let me take another sheet for you. So I will go for z transform of u of n. Okay, so that is our second term, right? Yeah, z transform of u of n is our second term. So you observe here. So this I will solve, and then I will go for this third term. Okay, then we have to add this up. So let us take the z transform of second term, which is z transform of u of n. Okay, so how can I write this one? So z transform of 1 power of n u of n. Why did I write this one? Because we know that z transform of a power of n u of n is equal to z by z minus a. So if I can express this 1 into u of n in terms of this formula, I can get our answer easily. So what is your a? A is 1. So z by z minus 1. So this is your second term. Then what you have to get? Z transform of your third term. So what was your third term there? Z transform of 2n u of n. Okay, so this was your third term. So how do you take the z transform? Let me take 2 outside first. So it will be 2 into z transform of n u of n. So we know one formula beforehand itself, which is z transform of n a power of n u of n is nothing but a into z divided by z minus a the whole square. So according to this one, if we can express, so I can write it as n, I'll write it as it is. Then a, instead of a, it is 1. 1 to the power of n is 1 only. So u of n, u of n. So now I have brought it in terms of formula. So a into z divided by z minus 1 the whole square. So express in terms of formula to get the answer easy. So we have got our third term, we have got the second term, and we have got the z transform of first term. Then what we have to do? We have to add all the terms together. So it will be your first term, which is z into z plus 1 divided by z minus 1 the whole cube, plus what is your second term? A into, sorry, z divided by z minus 1 the whole square, and your third term is z by z minus 1. So take the LCM, simplify this one. So you should arrive at answer as z cube plus z square divided by z minus 1 the whole cube. So simplification and all you have to do. Take the LCM, simplify this, and arrive at this answer. So let us see again what I have done. So given the problem, x of n is equal to n plus 1 the whole square into u of n. So I have expanded it and I have taken z transform of individual term using linearity property. So now it is in the form of n square u of n, expressed in the form of n into x of n, so that we can use frequency differentiation property and we'll get our first term z transform. Second one, again, it is in the form of 1 u of n. So you can express in the terms of z transform of a of n u of n is nothing but z by z minus a. So here a is nothing but 1 in your second term. So we can get z transform of second term easily. Similarly, third term, z transform of n a power of n u of n is nothing but a into z divided by z minus a the whole square. Here a is 1. So express in terms of that formula, get the third term, add together and simplify. It's easy. Okay. Just you have to remember the formulas, remember the properties. Okay. Then you can solve step by step. Okay. So now let me go to another problem here. So your x of n is nothing but n sine pi by 2 into n u of n. So again, n is there, x of n is sine pi by 2 into n into u of n. So what we can use? We can use this frequency differentiation formula. We can solve it. So what is the frequency differentiation formula? So according to frequency differentiation formula, n x of n property is nothing but minus z d by dz of x of z. So this is your property. So what you want? Z transform of n into your x of n, which is sine pi by 2 into n into u of n. So what is this one? Minus z d by dz of x of z is nothing but z transform of x of n. So your x of n is sine pi by 2 into n into u of n. So what's our major work here? To find the z transform of this term. So let us solve this one and substitute in this equation number 1. So z transform of sine pi by 2 into n into u of n. So we have to find this one. So what's the formula? So here you have to remember. So I have solved one problem. Okay. So z transform of sine omega naught n u of n. So go back to last two classes. I have solved this problem. So this you have to remember in order to solve this kind of problem. Z transform of sine omega naught n u of n is nothing but z into sine omega divided by z square minus 2 cos omega into z plus 1. So now what is your omega naught? Omega naught is pi by 2. So z into sine pi by 2 divided by z square minus 2 cos pi by 2 into z plus 1. So now you know sine pi by 2 is 1, cos pi by 2 is 0. So what we get here? Z by z square plus 1, because sine pi by 2 is 1, cos pi by 2 is 0. Then what we have to do? We have to substitute this one, whatever answer you have got in equation number 1. So minus z d by dz of z transform of this one, z by z square plus 1. So now it is your duty to simplify. Okay, simplify this one. I'll write it here, simplify, because these things you can do because you have done many problems in your PUC. It will take 1 or 2 steps. Okay, so you should arrive at an answer as minus z into minus z square plus 1 divided by z square plus 1 the whole square. Don't think why sir is not simplifying. If I keep on simplifying each and every sums, I'll not be able to cover wide variety of problems. So what you have to understand, you have to get the logic, the simplification. So differentiation of numerator by denominator, you people can do. Okay, so let us understand the logic of this question here. So given the question, x of n is equal to n sine pi by 2 into n u of n, I have expressed in terms of n into x of n. So we can use frequency differentiation property and we can get our answer easily, minus z d by dz of x of z. So x of z is nothing but z transform of x of n. So this part. So this part, in order to solve z transform, we have to remember this formula. Z transform of sine omega naught n u of n is nothing but z into sine omega divided by z square minus 2 cos omega into z plus 1. And what we have got in the question, omega as pi by 2. So substitute the value of omega and get them answer, and substitute back in this equation and simplify this. So you should get this answer. Okay, so why I'm not simplifying? Because you will not write and read. So if I simplify, you'll just you'll read it just like a textbook. So once if you write, once if you simplify this one, it will be easy for you. So major thing here is you have to write this one. Okay, always maintain a separate notes for this one. I'm repeating once again. So this signals, it is the basics for control system, DSP and many other subjects. So make sure you understand this Fourier transform, Z transform and the basics of signals. Okay, so in control system you'll be using this Z transform and conversion into Laplace transform, stability, all things. So that time you have to remember this formula. For example, I told you in the previous problem, Z transform of sine pi by 2 or Z transform of n sine pi by 2 into u of n. So those things there you will directly apply. So make sure whatever problems I solved, right side you write what is the Z transform and try to memorize the things. Okay, so again, based on the same I have given a homework problem here. Instead of in the previous problem I have solved n sine pi by 2 into u of n. Here a small difference, n cos pi by 2 into n into u of n. So these things you have to do. So you have to arrive at this answer here. Okay, I'm not giving homework problem which I have not solved. Based on the problems which I have solved only, I'm giving you the homework problems. Okay, okay, so let me go to another problem here. So x of n is equal to half power of n cos pi by 2 into n u of n. So by the look of it, which property can you use? You have to think. So in yesterday's class, I have done multiplication of an exponential in the time domain property. So what does that multiplication by an exponential in time domain property says? So that you have to write here, okay, which property you use correctly you have to write. So according to the property, z transform of a power of n u of n is nothing but x of z by a. So now what is your a? A is nothing but half. So z transform of half power of n cos pi by 2 into n into u of n you have got. So what is the z transform? X of z by a. A is nothing but half. So now we have to find x of z, which is nothing but z transform of this term, and then we will substitute in. So this we can write it as half will go above x of 2z. So first we will find z transform of this term. So that is our x of z, and then substitute instead of z 2z to get the final answer. So first what we will do, we will find this z transform of cos pi by 2 into n and u of n. So how can we solve this one? So again you have to remember one formula I have solved in the previous class. So z transform of cos omega naught n u of n is equal to z square minus z cos omega divided by z square minus 2 cos omega into z plus 1. So now what is omega? Omega is nothing but pi by 2. So put pi by 2. Z square minus z cos pi by 2 divided by z square minus 2 cos pi by 2 into z plus 1. So what is cos pi by 2? Cos pi by 2 is 0. So this term becomes equal to z square, because minus z cos pi by 2 is 0, divided by z square plus 1. So this is the z transform of this one. So what this is x of z. Our answer should be x of 2z. So the final answer, I'll write it here. So x of 2z, replace here z by 2z. So your final answer will be 2z the whole square divided by 2z the whole square plus 1, because we want x of 2z. So that is our answer according to this property. So see the problem, see in which form of property it is. So express in that property, and remember some of the formulas and get them answer easily. So that is the logic behind solving the properties of z transform here. It is very simple, okay. You can score easily in this z transform, Fourier transform easily. So all the steps are same in this Fourier and z. So it is methodical, okay. So there is no logic things here, okay. So now we will solve another problem. So what's the question here? X of n is equal to 3 power of n sine pi by 4 into n into u of n. Again, z transform of a power of n, x of n is nothing but x of z by a. So because it is in the form of a power of n, so this one again a power of n, x of n. So you can get your answer. So again you use that property. So using the exponential multiplication in time domain, so z transform is nothing but x of z by a. So write that property name fully, otherwise yeah, I'll cut the marks. So write the property, write what the property is, and then you substitute, okay. Always go step by step. I know you can remember the property directly, you can substitution you can do, but don't do that. Go methodically. First write the property, then write the formula for that property, and then you go step by step, okay. So what we have got, z transform of 3 power of n sine pi by 4n into u of n. So what is the z transform? X of z by a. What is your a? 3. So now what is x of z? X of z is nothing but z transform of sine pi by 4 in u of n. So how can we solve this z transform? So again you have to remember the formula. Z transform of sine omega naught n u of n is nothing but z into sine omega divided by z square minus 2 cos omega into z plus 1. So this is the formula you have to remember. I have solved this one. Okay. So now omega is pi by 4. So z into sine pi by 4 divided by z square minus 2 cos pi by 4 into z plus 1. So just I have substituted omega as pi by 4. Okay. So what is sine pi by 4? It is 1 by root 2. Cos pi by 4, it is 1 by root 2. So what's the answer? Z into 1 by root 2 divided by z square minus 2 into 1 by root 2 into z plus 1. So this is x of z. So what do we want? X of z by 3. So replace z by 3 in this equation and get the answer. So this is x of z. So whatever we have got here. So x of what we want? X of z by 3. So replace z by 3. So what you will get? Z by 3 root 2 divided by z by 3 the whole square minus 2 into 1 by root 2 into z by 3 plus 1. So again you have to simplify this one. So that is for you to do. So you have to arrive at an answer as z by root 2 by 3 into z square minus root 2 into z plus 3 root 2. Always simplify. Okay. I'm not going to do that one because it's for you to do. Otherwise, if I go on doing everything, what will you do? Okay. So that's for you to do. But I have given the logic properly. Before that, what you have to do. The simplification, it's your job. Okay. So yeah, let me wind up with the last problem here. Oh, I've already done this one. Okay. So observe the problem here. Find Z transform of x of n convolution x2 of n, where x of n is a power of n u of n and x2 of n is b power of n u of n. So which property we have to use? We have to use convolution property. According to the convolution property, convolution in time domain is nothing but multiplication in your frequency domain. So convolution, so Z transform of x1 of n convolution x2 of n is nothing but x1 of z into x2 of z. Okay. So what is x1 of z? Z transform of a power of n u of n. So x2 of z is nothing but z transform of b power of n u of n. So this one you know the formula, z by z minus a. Here also z by z minus b. Both you have to multiply and get the answer. So this is easy. So I'd written before itself and kept. Okay. So this property is easy. So I have solved many problems in Fourier transform also, if you remember. Okay. Okay. So yeah, in this class we had solved many problems with respect to properties. In the next class we will solve problems with respect to inverse Z transform, and then again we'll see what is that unilateral Z transform, and we can wind it up. Okay. Okay, guys. Bye.